Thank you everyone. How are you? তোমরা সব কেমন আছো? My channel name is Vidyut Flow. You may subscribe if you like it. Today we start a new lesson known as alternating current. The level is joint IIT preliminary level. The impedance of a RC circuit is Z1 for frequency F and Z2 for frequency twice F. Then Z1 is Z2. Omega dash square C square. This one for frequency F and this one for frequency twice F. Because we know omega equals twice pi F, where F is the natural frequency and omega is the angular frequency. Sixteen pi square F square C square R square plus 1 this divided by sixteen pi square F square C square R square plus 4 this divided by 16 pi square F square C square R square plus 1. Now, 16 pi square F square C square R square very greater than 1 because all are positive quantities and all are square values. So 3 by is very well less than 1. So what is there? So implies Z1 upon Z2 is 1 plus something. So it is 1 plus something. So answer will be this, between 1 and 2. Answer A. A resistor R and a 2 microfarad capacitor are connected in series through a switch to 200 volt direct supply. Across the capacitor is a neon bulb that lights up at 120 volt. Calculate the value of R to make the bulb light up 5 seconds after the switch has been closed. So for charging a capacitor, we have I equals to I0 1 minus e to the power minus t upon tau equals to I0 1 minus e to the power minus t upon RC, where tau equals to time constant equals to RC. Here, when there is no statement about current, there is statement about voltage. So V equals to E whole into 1 minus e to the power minus t upon RC. Why this one takes place? Because when this both ends are multiplied by resistor, then we get V. Though when both ends are multiplied by the resistance of capacitor, then we can write this. So this is 120 volt according to our problem. This is this, and this is 200 1 minus e to the power minus 5 upon 2R into 10 to the power minus 6. This supplying the data given. So we can write equals to 2 by 5 implies e to the power 5 upon 2R into 10 to the power minus 6 equals to 5 upon 2 equals to 2.5. That 2.5 comes here. So 5 upon 2R into 10 to the power minus 6 equals to log of 2. Taking both sides, taking logarithm on both sides. Here is the base is E, that is Eparian base. We have to transfer this base into binomial base, that is decimal base, that is decimal base, that is 10. So 5 upon 2R into 10 to the power minus 6 equals to 2.303 into 10 to the power into log of this 10. Log of 2.5 to the base 10. So we can write R is equals to into this one given here. So 0.4. So R equals to into 0.8 into 10 to the power 6 equals to 7. So answer will be 2.7 into 10 to the power 6 ohm. So this one answer B. Number 3 problem says to us an AC current is given by this I equals to I0 plus I1 sine of omega t. Then its RMS value is this. It's a mere mathematical calculation only. We know IRMS equals to root over I square dt, this divided by dt. By definition, this is root and this is mean square value of current I. This is the mean square value tt. Cutting out we get I square mean and root of it is root mean square value. The answers are solved here in a very easiest process so as to each and everybody can grab the process. Whole square into dt this divided by capital T, because dt integration dt is t and its capital T is the upper limit, G is the lower limit. So ultimately we get this as capital T. Sine square omega t plus twice I0 I1 sine omega t dt upon t. This is integration. So this one can be written as I0 square dt plus twice I0 I1 sine omega t dt plus I1 square by 2 dt this divided by t. Because this is by 2, multiplying by 2 we get 2 sine square omega t. We know 2 sine square omega t equals to 1 minus cos 2 omega t by trigonometrical relation. cos omega, omega t equals to twice pi. So cos twice pi equals to 0 and cos twice pi equals to 1 because cos twice pi equals to 2 cos square pi minus 1 equals to 2 minus 1 equals to 1 and cos 0 equals also 1, so this term is vanished. So this term present and this term also sin of omega t equals to sin of 4 pi equals to 0, sin 0 0, so this term also vanished. So these two present I1 square by 2. So I0 square plus 0.5 I1 square. This is I RMS. So answer A. To find the RMS value of potential difference V shown in the figure. Here is a figure given. We have to find the VRMS. So VRMS equals to 0 to T V square dt, this divided by 0 to T dt, and this root mean square value বাংলা বলে মূল গড় বর্গ মান। এখানে আমরা দেখতে পাচ্ছি আমরা from 0 to T by 2 V value is V0. From 0 to T by 2 V's value is V0, so we can write V0 square dt plus T by 2 to T. From T by 2 T, this value V value is 0, so we can write 0 into dt, this divided by from 0 to T by 2, the value from 0 to T by 2 dt from 0 to T by 2, so and from T by 2 to T, you can write 0 to T by T dt. So 0 to T by 2 also from T by 2 to T, total length is covered by time. So here V0 square into T by 2, this divided by T equals to 0 upon root 2. So answer C. In a series LCR circuit, the frequency of a 10 volt AC voltage source is adjusted in such a fashion that the inductive and capacitive reactances are 15 ohm and 11 ohm respectively. If the resistance is 3 ohm, then 4 answers given here. This question is of LCR circuit. So first we have to find the impedance. Z equals to R square plus XL square minus XC square, where XL is the reactance of the inductive part and Xc is the reactance of the capacitive part. Because we know R square plus omega L minus omega 1 by omega C, this whole square, Z is equals to. So here was mistaken. Here omega L equals to XL and 1 by omega C equals to XC. So this will be this. So this will be 1, 5. So I equals to 2 ampere. So the voltage, the current is this one is wrong. The voltage across resistor. Number B, voltage across resistor 2 into 3 equals to 6 volt. This one is right. B is the right answer. Voltage across in the inductor 10 volt. 15 into 2. Because the voltage across the inductor is I into XL equals to 2 into 15 equals to 30 volts. So voltage across the inductor is also wrong one. And number D, voltage across the resistor is constant of L and C. And number so VC equals to I, XC equals to 2 into 11 equals to 22 volts. So VL minus VC equals to 30 minus 22 volt equals to 8 volt. So the answer is D. So answer D and D. Why this one is minus? Because here XL minus XC term comes here, impedance, and also for VL minus VC term comes for impedance, inductive and capacitive reactances. So this one is 8 volt, this one is minus sign present here, so 8 volt is answer B and D. This is a problem which is to be calculated to answer the following problem. And this problem is not a MCQ type problem because this one to be calculated to find the average power dissipated in the circuit. Find the question written as find the expression for average power dissipated for V equal to this and I equals to this. So answer to the problem, average power equals to Vi dt this divided by this is power V into I is the quantity known as power quantity, and dt by integrating dt you get average power equals to 0 to t V0 I0 sin omega t sin of omega t minus phi this divided by t equals to V0 I0 upon twice t 2 sin omega t sin of omega t minus phi dt. V0 I0 upon twice t cos of dt 0 to t. Here applying the formula 2 sin A sin V equals to cos of A minus B minus cos of A plus B at the cluster level. We've written this, so applied here. V0 I0 upon twice t omega t equals to twice phi. So we get sine of 4 pi minus phi upon twice omega minus of sine phi upon twice omega, because sine of minus theta equals to sine minus sine theta. Sine of minus theta equals to minus sine theta. So we know sine of even multiple pi by 2 plus minus theta equals sine theta. So we get, because by all sine tan cos the angle remains here, so this will be negative. So we get here equals to V0 I0 upon twice t cos phi t minus sine of phi upon twice omega minus sine of phi upon twice omega equals to V0 I0 cos phi upon 2. So the answer to the question is equals to V0 I0 cos phi upon 2. This will be applied in the following problem. When a voltage V 200 root 2 sine of omega t plus 15 degree is applied to an AC circuit, the current in the circuit is found to be this, I equals to twice sine of omega t plus pi by 4. Choose the correct option or options. Average power consumed is 200 root 6 watt. Average power consumed is 100 root 6 watt. Power factor is root 3 by 2. Power factor is half. The previous problem, notice the previous problem where there was V equal to V0 sine of omega t, I equals to I0 sine of omega t minus phi. So average power consumed equals to half V0 I0 cos phi. What is phi? Phi is the difference of phase angle between voltage and current. So, what is V0, what is I0, you know it. So, put this here. Here V equals to 200 root 2 sine of omega t plus 15 degree. I equals to 2 sine of omega t plus 45 degree. Pi of 4 equals to 45 degree. So, we get phi as 45 degree minus 15 degree equals to 30 degree. So, cos phi equals to cos of 30 degree equals to root 3 by 2. The difference says as phi, here is plus 0, you can say omega t plus 0, so 0 minus of minus phi equals to plus phi. So you can write 15 minus of 45, you can get minus 30, but cos of phi equals to cos of minus phi. So there is no person here. You may take whatever you may like. So power average power equals to half V0 means 200 root 2 I0 means 2 cos of phi means root 3 by 2. So this is cutting out xo equal to xo root 6. Xo root 6 what? So B is answer and power factor is root 3 by 2, so C is also answer. Answer B and C. Number 8 problem says to us an inductor of inductance 2.0 millihenry is connected across a charged capacitor of capacitance 5.0 microfarad and the resulting LC circuit is set oscillating at its natural frequency. This setting is taken into oscillation form. It is found that the maximum value of the instantaneous charge on the capacitor is 200 microcoulomb. Find the maximum value of the current in the circuit. Find the maximum value of the current in the circuit. This problem, so for oscillation, we know L omega equals to 1 by C omega. L omega equals to implies omega equals to 1 by root over LC equals to 1 by root over 500 to the power minus 6 equals to radian per second. Now, it is found that a maximum value of the instantaneous charge. Now, charge flowing through the circuit. Let Q is the charge which is flowing through the cos of omega t, because this is this pattern obtained for this I for I also for B also in this pattern. So we can write q equals to, so dq upon dt. This is the I. If q is taken into this form, then dq of dt equals to q0 omega sine omega t minus. So I max equal to q0 into omega. q0 given as 200. Instantaneous charge, it is found the maximum value of the instantaneous q0 200 microcoulombs into 10 to the power minus 6 into omega equals to 10 to the power 4. So 2. So I max equals to 2 ampere. So answer C. This is all about to our class of alternating current. This chapter is closed in only one shot only. All the problems are solved in a lucid manner. A few problems remains which are of easy process, which are of easy. So the shortcut collected questions are taken here to solve the total chapter in one shot. You may subscribe my channel Vidyut Flow. Thank you.